Hi, all right, welcome to lecture 13. In this lecture, we're going to do more stuff with our friend the mole. So we're going to do more things with mole calculations. Now, some of these can be a little tricky. So before we get into any new calculations, which will be in part B and C, in part A, we're going to do a little review of what you heard about last time. So what we were doing last time, yeah, there was a lot of different problems, but all of them can be summed up in this one diagram. We talked about how you can convert between grams and moles, and then how you can convert between moles and particles. All right. So we're going to do a few more going between these three ideas, grams and moles. So just to remind you, the way you go between grams and moles is you have to look up the number on the periodic table, or maybe if it's a compound, you need to add up the numbers on the periodic table. And whenever number you see on the periodic table, underneath the symbol, that always, I promise, is how many grams makes a mole. So you can use that periodic table weight to convert between grams and moles. Now, we also did some problems where we're going between moles and particles. Moles and the little things that make up the world. Now, those little things have different names. Atoms, maybe molecules, maybe formula units. So why are there three different terms? It depends on the kind of substance, right? Atoms, molecules, and formula units. It depends on whether we have an element or a compound, really. All right. So how do you go between moles and any of those things? That's where Avogadro's number comes in. 6.02 times 10 to the 23 is a mole. And next to Avogadro's number, depending on what we got, you might either have to say atoms, or if it's a compound, we'll say molecules, or if it's an ionic compound, we'll say formula units. So knowing these conversion factors and when to use them, that's really what you kind of got to get used to, okay? So grams and moles, you use the periodic table. Moles and particles, you use Avogadro's number. All right, so with that little introduction, we're going to do a few more examples, all right? So let me flip over and we'll get going on one. Oh, actually, before we do an example, let's just do a little question about a little review question to see if these terms make sense or not, okay? So there's 5 statements here. Which ones are true? All right. A mole of carbon weighs 12.01 AMU. All right. A mole of carbon weighs 12.01 grams. A mole of carbon is 6.02, they give you one extra digit in this one, 6.022, they say, times 10 to the 23 atoms of carbon. So which of those are true? Could be just one of them, it could be 2 of them, could be all 3 of them. Which ones are true? What do you think? Well, let's go down the list. All right. 1 mole of carbon is 12 AMU. That is not correct. 1 atom of carbon weighs 12 AMU. So 1 atom of carbon weighs 12 AMU. A ginormous number of carbon atoms together. We call that ginormous number of carbon atoms together a mole. A mole of carbon weighs 12 grams. So that the second one is true, but not the first one. A mole of carbon does not weigh 12 AMU. A mole of carbon weighs 12 grams. Now another one that's true actually is C. A mole of carbon is 6.02 times 10 to the 23 atoms of carbon. So B and C are actually correct, all right? All right, so with that, a lot to keep track of in your head, isn't there? Let's do a little math example. All right, let's move on. All right, so our first example in our little review, a few more with moles. How many moles are in 5.672 grams of iron 3 sulfate? How many moles are in 5.672 grams of iron sulfate? They're giving us grams. They're wanting us to solve for moles. How many moles? So Are you going to be using the periodic table, or are you going to be using Avogadro's number? What do you think? Periodic table or Avogadro's number? Oh, I hope you know it's the periodic table. So the periodic table is going to help us go from grams to moles. All right. So the other thing we need to do before we can use it, though, right, is when we say use the periodic table, what I really mean by that is we need to know the weight off the periodic table, right? Because that weight off the periodic table is going to be our conversion factor. All right. So before we can add up the weight, we need to know the formula. So first thing I'm going to really do, once I realize, oh, the periodic table is going to help me out, I need to write out the formula for iron 3 sulfate, and then I need to add up the atoms that are inside of it. So let's do a little review of writing formulas. Iron 3 sulfate, Fe is iron. What's the 3? The charge. Iron 3, that's it. Sulfate. Sulfate is a polyatomic. It is SO4 2 minus. Now, if you want to put them together, when you balance out the charges, you need another iron. That gives you 6 positives. And to balance out the charges, you would use 2 more sulfates. And now we're balanced. 6 positives, 6 negatives. So the right formula is FeSO4 3. Oh, Fe2. I left out the 2 there by accident. All right, now we know what the heck is in this compound. So you got to have the formula. You got to have the formula. And now we're going to add up the weights off the periodic table for all those atoms. And that should give us our conversion factor to go from grams to moles. All right, so let's go ahead and add up the weights. 2 irons. And then look at that formula. How many sulfurs are there? There's 3 times 1, right? 3 times 1, 3 sulfurs. And how many oxygens do you think? 3 times 4, 12 oxygens. All right, so let's go ahead and add them all up. 2 irons. 3 sulfurs. So I'm using the weights under the symbol, right? Getting them from right here. That's where those numbers are coming from. Oxygen 16. All right. So if you add it up, this is what you get for iron. This is what you get for the sulfurs. Oh, let me check my notes. I have it written down so I don't have to do it again. 96.21. And this is what you get for the oxygens, 192. The grand total, when you add them all together, is 399.91. That's all those atoms put together. Now, oh my, there's got to be a unit there, right? This is a conversion factor. 399.91 what? Grams makes a mole, equals a mole. All right. All right, so we have our conversion factor now. The weight off the periodic table is how you get from grams to moles. So last thing you got to figure out when you're ready to use it up here, do you multiply by 399 or are you going to divide by 399? What are you going to do? Oh, I hope you know you need to divide. So you would divide by 399. 399.91. Grams goes on the bottom. Oh yeah, I want that to cancel. Yeah, that's going to cancel. 1 mole goes on top. It should look like that. Now, if you type in your calculator, I worked it out. What I came up with was 0.01418. All right, grams to moles, moles to grams, anything with moles and grams. Either way, you use your periodic table, which means you need to add up the weight. So adding up that weight, that's called the molar mass, right? All right, let's do a few more. Oh, we got to get good at this stuff. All right, let's move on to another example. All right, so next example. So for this one again, just watching me do problems. I hope it helps you a little bit, but you really need to practice. So I'm gonna let you kind of work on this one, all right? So let's read it. It's kind of similar to one I just showed you, but let's make sure you got it figured out. So it says, how many moles are in 5.6 grams of lithium nitride? How many moles are in 5.6 grams of lithium nitride? So you have 5.6 grams of this. How many moles do you have? You're converting from grams to moles. All right, now before you can do that, just like I had to use, you have to know the weight off the periodic table, right? And before you can find the weight off the periodic table, you need to know the formula for lithium nitride. Lithium nitride. All right, So what's the formula for lithium nitride? Okay, I hope you know lithium is +1, nitride was -3. So I hope you got lithium with its plus charge, nitride with its -3 charge. It should be, oh, what would it be? It would be Li3N. You need 3 lithiums. All right, so there's your formula. All right, so with that, that kind of gets you started. I think I'm going to let you figure it out for the rest of it. I'm not going to, let's see if you can do it. So it's multiple choice, so it's one of those 3 answers there. Which one is the right answer? Which one is the right answer? I'll let you work on it. All right, hopefully you got that right. If not, hey, you can ask me some more questions. We'll do another example or 2 on this video related. And of course, you can talk to me in Zoom time. I hope you got that one right. All right, so with that, let's move on a little bit more. Grams and moles and molecules, all this stuff. Let's do a couple more. All right. All right. This one is, how many formula units are in 2.45 grams of chalk? And the official chemistry name of chalk is calcium carbonate. So how many formula units are in 2.45 grams of chalk, calcium carbonate? So let's see. I know that I'm starting off with that amount of chalk, 2.45 grams, and I am trying to get to formula units. Now, we're going to work on this kind of together, but I want to make sure you can kind of have an idea what the heck you got to do. So first thing, let me ask you a little question. If you are going from grams to formula units, how many steps is this going to take you? How many steps is it going to take you? Okay, I hope you know it's going to take you 2 steps. You're going to go from grams to moles, and then you could go from moles to formula units. So this means we're going to have to use our periodic table. Grams to moles. Oh yeah, that's the periodic table. It's kind of like the last ones we did, isn't it? And then moles to formula units, just like we're going moles to atoms or moles to molecules. Anytime you're going to any of those particles, we have to use our Avogadro's number, 6.02 times 10 to the 23. All right, so we're going to need to do 2 steps. Grams to moles, periodic table, please. And then moles to formula units, 2 steps. Okay, now let's see if you can also help me out a little bit here. To be able to do this first step, grams to moles, hey, that's the periodic table. Hey, you got to know the formula, because how are you supposed to add up the atoms if you don't know the formula? So what is the formula for calcium carbonate? What's the formula for calcium carbonate? Oh, I hope you know. It is, let's see, calcium carbonate. Calcium is Ca. It's +2. And then you had to know what carbonate is. Carbonate, ATE, that's a polyatomic. It's on your handout. I'm not going to show it to you. It's a little hard to put all this on the screen at once. So carbonate, 888, polyatomic. This is its formula. So when you put it together, the right formula should just be CaCO3. All right, so that's what you should be adding up. Okay, so let's go ahead and do it. All right, so this is our formula. We're going to add up these numbers off the periodic table to get our conversion factor to go from grams to moles, to use the periodic table. All right, in that formula, 1 calcium, 1 carbon, 3 oxygens. Carbon, 40.0, sorry, calcium, I should say, 40.08. Carbon, 12.01. That's a 0 there. Times 16. That's the weight for oxygen. So if you put it all together, and shoot, I should have a little more room here. It's going to be hard to show you all the work exactly. Let me just tell you. When you add it all together, you should be getting, let's see what I got here. Where's my number? 100.09. 100.09. All right. Now that's a conversion factor. Remember, when you add up the weights off the periodic table, that is how many grams, right? How many grams equals a mole? All right, so it's 100. So what are we going to do with that 100? Well, let's look at our work here. If that's your conversion factor, 100 grams is a mole, we are trying to get rid of grams. So put the grams on the bottom, put the 100 right here with it. That's what I see in the conversion factor. The 1 mole goes on top. All right, so grams would cancel. We'd have moles now. All right, so with that, let's move on to the next step. So we're now going to do moles to formula units. Moles to formula units, Avogadro's number. Now let's be a little bit more exact. Avogadro's number says, maybe I should, I'm going to erase some of this. All right. Avogadro's number says that what did it say? It says 6.02 times 10 to the 23 is a mole. And next to Avogadro's number, sometimes you write atoms, sometimes you write molecules. We are going to say formula units. So there's 3 options in that blank. Right here, there's 3 things you might write. Depends on the kind of substance. Right now, we're going to be writing formula units because this is an ionic compound. So we'll write formula units here. Okay, so now let's go ahead and do it. So we have moles here. So we need to put, all right, here we have moles. So we got to get moles to go away. Put moles on the bottom. So I'm going to put this side on the bottom. And I'm going to put the right-hand side, this, on the top. 6.02 times 10 to the 23. All right, that's looking pretty good to me because moles is going to cancel. I don't want you moles. Go away. I want formula units. So if you work it out like that, I think it's going to work. All right, so if you work it out, I did it earlier. I got number B right here. It actually works out to be this number. Should be 1.47 times 10 to the 22 formula units. All right, so grams and moles, periodic table, moles and formula units. You got to use Avogadro's number. In this case, we were going all the way from one end of this diagram all to the way to the other. So that means you had to use both of them actually, right? All right, so, let's try one last one. Let's try one last one. All right, our last problem on this video, a little bit more with grams and moles and molecules. All right, last example. What is the mass? So when I say what is the mass, what does that mean I'm solving for? Grams. What is the mass? How many grams? What is the mass of 4.55 times 10 to the 23 copper atoms? All right, so you have 4.55, that's our given number, times 10 to the 23 atoms of copper. Oh, and you know what? I should probably write atoms here. Let's be better. Let's be more careful. And I want to know how many grams does this weigh? All right, so you're going to go from atoms to grams. Let me give you a little hint. I think it's going to take you 2 steps, right? You're going to have to go, like here are our 3 ideas. And then particles. Particles is really, in this case, atoms, right? So you're going to have to go from atoms to moles, moles to grams. You know, I think I'm gonna let you work on this one. All right, so the only hint I'll give you, you need to read the periodic table at some point. It's a little hard to read right here because I have to make it so small to fit on this screen. For copper, it says 63.55. That's what it says for copper. All right, so it's multiple choice. There's 5 answers there. So let's see if you can work it out. What's the right answer? What's the right answer? How many grams is this? How many grams is this? Copper. Okay, hopefully you got that one right. If not, you know, we're going to go over it and we'll talk about this stuff in Zoom time again, get you some more examples if you're a little mixed up, a little confused. You can also email me or, you know, call me and I can try to help you out that way. So we'll be doing more stuff with moles pretty much the rest of the semester, right? So it comes up quite a lot. So hopefully you're starting to get used to it. If not, let me know and I'll try to help you out. With that, that's the end of part A. So in part B and C, we're going to move on to other calculations with moles, ones you haven't seen yet. So we'll get to that in just a bit.